Hi, welcome to my farm. This buried 2-gallon clay pot can water a garden pocket through a 90-day growing season. It cannot do that on one fill. That is the first honest number. I bring years of experience with dry soil, where surface watering disappears before roots use it. Today, I am sharing 8 parts that turn an unglazed pot into measured root zone irrigation. A basic build can start near $20. It needs no pump, timer, pressure regulator, or electricity. Please watch until the end, because each part builds on the last. Miss the spacing, clay test, or refill math, and the plan fails. Part 8 is the one that ties everything together into a 3-month Olla bank. University of Arizona's 2021 guidance reports 60 to 70% water savings against watering can irrigation. But the real payoff is control. Every refill becomes a soil test, a leak test, and a water budget you can see. Part 1 of 8 is the clay test. Budget $10 to $80 per vessel. Start with unglazed, low-fired terracotta. Avoid glazed walls. Avoid sealed decorative pottery. Water must cross the clay. Fill the empty pot above ground. Set it on a dry board. Mark the water line. Wait 2 hours. The outer wall should darken evenly. You may see cool dampness. You should not see a stream. A visible leak means a crack. No dampening means the body is too dense or sealed. Measure capacity with a 1-gallon jug. Write the number on a garden map, not the pot. A 2-gallon vessel holds about 7.6 liters. A 3-gallon vessel holds about 11.4 liters. Capacity matters because refill intervals alone can mislead. A tiny pot lasting 4 days may release less water than a large pot lasting 2. Choose a broad belly and narrow opening. More buried wall gives more delivery area. A narrow neck reduces evaporation and keeps mulch outside. Leave only 1 to 2 inches of neck above grade later. University of California guidance published in 2024 gives that same burial range. Here's the part most garden videos skip. The clay controls the system before the plant does. 2 pots of equal size can release water differently. Firing temperature, wall thickness, mineral deposits, and cracks change the rate. Never buy 12 vessels before testing one. Test 3 samples from the same batch. Record 24-hour loss. Keep the most even pair. Part 2 of 8 is the sealed DIY Olla. Budget $15 to $45 for 2 terracotta pots, a small tile, and water-safe sealant. A purpose-made Olla may cost more. The physics stays the same. For a single pot build, cover the drain hole from inside. Use a flat tile larger than the hole. Apply sealant rated for continuous water contact. Let it cure for the full label time. That may be 24 to 72 hours. Do not guess. For a larger build, join 2 matching pot rims. Seal 1 drain hole. Leave the other open for filling. Colorado State University Extension gardeners describe this paired 7-inch pot method. Their finished vessel holds about 1 gallon. Leak test outside for 24 hours. Reject any seam that beads water. Then rinse the vessel. Never use paint inside. Never use an unknown chemical container as a reservoir. Clay is simple. Contamination is not. Cover the fill opening with a fitted saucer, stone, or lid. The cover limits evaporation. It also blocks soil, insects, and mosquitoes. Secure it against wind and animals. Do not seal it permanently. You need access for filling and inspection. Now the vessel holds water. Next, the hole decides where that water goes. Part 3 of 8 is the installation pocket. Budget $0 to $30 for compost, mulch, and a marker. Dig the hole before planting. Moving an Olla beside mature roots causes damage. Set the vessel upright. Bury the body completely. Leave 1 to 2 inches of neck exposed. Pack moist soil firmly against every clay surface. Air gaps break contact. Water cannot cross an empty pocket into the root zone. Backfill in 2-inch lifts. Press each lift by hand. Do not ram hard enough to crack the pot. Fill the Olla. Then soak the surrounding bed once from above. This first surface watering settles soil and creates continuous contact. Place a marker beside the neck. Use a painted stake or stone. Never put weight on the lid. A buried Olla can disappear under vines by midsummer. 1 careless boot can end the season. The 2001 Agricultural Water Management Review describes this system as a buried, unglazed, porous pot filled with water. It also warns that performance changes with soil, crop, management, weeds, and microclimate. That boundary matters. Part 4 of 8 is the spacing map. 1 pot does not water an entire raised bed. It waters a pocket. Start with a coverage diameter near 2 times the vessel diameter. University of Arizona calls that anecdotal, not universal. An 8-inch pot may serve roughly a 16-inch circle. A separate maze study suggested 20 to 30 centimeters in its conditions. Those numbers are starting points. University of California gardeners place many ollas every 2 to 3 feet. Vessels holding 2 gallons or more may reach 3 to 4 feet apart. Sandy soil can move water outward differently from heavy clay. Dense clay may hold water too tightly near the vessel. Test your bed. Use a simple 24-hour moisture map. Fill the olla. Mark points 6, 12, 18, and 24 inches away. The next day, dig narrow inspection holes 4 to 6 inches deep. Feel the soil. Better, use a clean wooden dowel. Dark, damp soil marks the active radius. Plant tomatoes, peppers, squash, melons, and similar fibrous-rooted crops near that radius. Keep woody roots away. Arizona Extension warns that woody roots can break the clay. Avoid claiming one olla will serve dense rows of shallow annuals. UC guidance calls that use inefficient because too many vessels are required. Make the map before buying more pots. Count active circles. Overlap their edges slightly. Leave paths dry. A dry surface can reduce some weed pressure. It does not mean the root zone is dry. Here is the honest part. Ollas are not magic during germination. Seeds need moisture in the top 1 to 2 inches. New roots cannot drink from a clay wall they have not reached. Surface water the seed line until establishment. The next module shows exactly when to stop. If these first 4 parts changed how you see irrigation, hit subscribe. The next 4 turn a buried pot into a measured 90-day system. But installation has a ceiling. The pot can release water only where soil touches clay. Young roots may still sit outside that zone, which is why the first month needs a separate plan. Part 5 of 8 is the establishment bridge. Budget $0 to $20 for a small watering can and 2 wooden moisture probes. Plant 4 to 8 inches from the vessel, depending on its tested radius. Keep the stem away from the lid. Fill the olla completely. Water the transplant from above. For the first 7 days, check the root ball each morning. Give surface water when that root ball is drying. Do not flood the entire bed automatically. During days 8 through 21, widen the interval between surface waterings. Check at 4 inches deep. Let the plant follow moisture toward the olla. Watch new leaves at midday and again after sunset. Temporary midday droop can occur in heat. Droop that remains after sunset signals a problem. Arizona's 2021 extension says new transplants may need supplemental water for up to 1 month or more. That is the safe expectation. The olla works immediately. The roots do not. Here is the number that protects the crop. 30 days. Treat the first month as training, not proof of failure. By week 4, test 1 plant. Stop its surface water for 48 hours in moderate weather. Keep the olla full. Check the root zone soil twice daily. If moisture holds and growth stays normal, the bridge is working. If not, restore surface water and adjust spacing. Part 6 of 8 is the refill log. Budget $5 to $25 for a marked dipstick, measuring jug, or simple float. Never refill blindly. Measure what left. Check at the same hour daily for the first 14 days. Insert a clean dipstick. Mark full, half, and quarter levels. Add water with a measured jug. Record gallons added, maximum temperature, wind, rain, and plant stage. Refill frequency may range from every other day to 7 days or more. University of California gives that broad range because weather, soil, density, and pot size all matter. A rigid weekly promise is false. Suppose a 2-gallon olla takes 1.5 gallons every 3 days. That is 0.5 gallon daily. Across 90 days, it delivers about 45 gallons. 4 identical ollas deliver about 180 gallons. The number is site-specific. The method is universal. Do not wait until bone dry. Refill near 25% remaining during heavy fruiting. Water movement can slow as the head drops. A dry olla also leaves no reserve for a hot afternoon. Rain changes the draw. Wet soil reduces the moisture gradient. More water may remain inside. That is useful feedback. If the pot empties suddenly after stable weeks, suspect a crack, disturbed seam, animal damage, or a new root load. 6 parts now deliver water. Part 7 decides whether the system lasts 3 months without hiding a shortage. Part 7 of 8 is the 90-day budget. Budget $20 to $120 for mulch, spare seals, and 1 reserve container. The clay pot does not create water. It only delivers stored water more carefully. Start with the measured daily draw. Use the hottest reliable 7-day average, not the coolest week. 4 ollas at 0.5 gallon each use, 2 gallons daily. Over 90 days, that is 180 gallons, at a 20% reserve. The season budget becomes 216 gallons. Now convert that into trips. A 5-gallon can requires about 44 full carries. A 55-gallon barrel covers roughly 27 days at 2 gallons daily before losses. 4 barrels cover the 90-day estimate with margin. A single barrel does not. That is the buried truth. Waters for 3 months describes the service period. It never means one fill lasts 3 months. The 2024 University of California guide says plants avoid water stress only while the gardener keeps the olla filled. Colorado Extension gardeners in hot, windy Pueblo conditions refill their roughly 1-gallon paired pots every morning. Other sites last a week. Climate writes the schedule. Most failures begin with borrowed refill claims. Cut demand before buying storage. Add 2 to 3 inches of organic mulch. Keep mulch outside the fill neck. Remove weeds inside the wet radius. Shade bare soil with crop leaves. Group plants by demand. Do not place lettuce, tomato, and rosemary on one assumption. Make 3 operating lines. Green means above 50%. Amber means 25 to 50%. Red means below 25%. During fruit set, refill at amber. During cool rain, observe before adding water. During absence, arrange a person or a gravity feed. A lid is not a caretaker. If you are building this system, add your measured pot size and refill interval in the comments. That field number is more useful than a generic claim. Run a 7-day absence test before leaving. Fill every olla. Measure the header reserve. Simulate the expected draw with outlet tests. Check every joint. Then have someone inspect on day 2 and day 5. Do not use a vacation as the first trial. The 2001 Buried Clay Pot Review reported that some systems may need water only weekly. It also called for more trials matching porosity and surface area to crops, climates, and soils. Use both statements. Efficiency is promising. Certainty is local. 7 parts can run 1 bed. The final part connects them without adding pressure, electronics, or guesswork. Part 8 of 8 is the gravity-fed olla bank. This is the one that ties everything together. Budget $60 to $300 for a covered header tank, food-safe tubing, shut-off valves, tees, and float controls. Start with 2 ollas, not 20. Place the header tank above the bed. A rise of 2 to 4 feet gives gentle head. High pressure is unnecessary and may expose weak seals. Fit a bottom outlet, isolation valve, filter screen, and main line. Keep the tank covered and opaque. Feed each olla through its lid or neck. Use a small float valve designed for low pressure. Secure the tube. The valve should close before water reaches the rim. Leave an airspace. Test each branch over a catch basin first. Arizona's 2021 extension describes tubing linked to ollas and gravity flow from a larger tank. It also notes compatibility with rainwater storage or delivered water. That turns hand filling into controlled replenishment. It does not remove maintenance. Balance the branches. Fill the header. Close all valves. Open the farthest olla first. Then open the others. Watch 30 minutes. Every vessel should stop at the same safe level. A branch that keeps flowing has a valve or seal problem. That is loop A closed. The tested clay controls release. The spacing map controls coverage. The first month bridge trains roots. The refill log measures draw. The 90-day budget sizes storage. The header tank replaces repeated carrying. 1 system. 8 checks. Add a main shutoff where you can reach it quickly. Add branch valves for isolation. Label each tube on the garden map. Protect tubing from sunlight, trimmers, rodents, and feet. Keep connectors above mulch where possible. Check the header every 2 days during the first month. Compare header loss with summed olla draw. A large difference signals leakage. A small difference may reflect measurement error. Investigate before increasing storage. My farm rule is simple. Clay handles delivery, the log handles truth. A gravity tank can extend autonomy. It cannot promise 90 unattended days. The longest safe interval is the shortest proven reserve, branch, or inspection interval. Now, what no one else making this kind of video will tell you. Part 1 fails when the clay is glazed or too dense. Part 2 fails at a rushed seam. Part 3 fails across an air gap. Part 4 fails when spacing comes from a product claim. Part 5 fails when young roots receive no bridge water. Part 6 fails when nobody measures draw. Part 7 fails when the reserve ignores heat. Part 8 fails when one float sticks open. Salts can clog pores. Roots can wrap the vessel. Woody roots can crack it. Dense clay may keep the wet zone narrow. Sandy soil may demand closer spacing. Direct sown seeds need surface moisture. Densely planted annual rows may need another method. Inspect lids weekly. Brush necks monthly. Flush header screens. Watch for algae. If refill frequency suddenly doubles, isolate the pot and leak test it. Do not pour bleach, fertilizer concentrate, or pesticide into the Olla. Keep the reservoir for irrigation water. Hard freezes can break wet terracotta. UC's 2024 guidance says to remove Ollas before severe winter freezes. Empty them. Dry them. Brush off soil and roots. Store them protected. One bonus test costs nothing. Place one empty food can at 6 inches and another at 12 inches from the Olla. Bury both open ends level with the 4-inch root zone. After 24 hours, lift a small soil sample beside each can. Compare moisture by feel and weight. Do this before and after mulch. The result shows your real radius better than a catalog diagram. 8 parts, 1 measured season. Here is the master list. Part 1 tests porous clay. Part 2 seals the vessel. Part 3 creates soil contact. Part 4 maps the wet radius. Part 5 bridges the first 30 days. Part 6 measures refill demand. Part 7 funds 90 days. Part 8 links the bed to a gravity reserve. Under $50 can build and test one simple Olla. Around $100 can equip a small bed with several DIY vessels. From $60 to $300, a gravity header can reduce carrying. Your actual price follows vessel size, tubing, storage, and local materials. Use the season math. A 2-gallon Olla losing 0.5 gallon daily needs about 45 gallons across 90 days. 4 need about 180. Add 20%. Store or schedule 216 gallons. Then adjust with measured weather and plant demand. University of Arizona cites 60 to 70% water savings versus watering can irrigation from a 2017 study. A 2024 field comparison in Kenya reported much larger applied water savings for maize and tomatoes against furrow irrigation. Those are specific trials, not a promise for every garden. The older evidence matters too. A 2001 review traced written buried pot irrigation in China beyond 2,000 years. It found strong efficiency, potential, and serious variation. The technique survived because the mechanism is simple. Drying soil draws water through porous clay. Rain-wet soil slows that movement. Roots gather near the source. That is not nostalgia. That is a controllable pressure gradient. Start with 1 pot and 1 crop. Test clay for 24 hours. Map moisture at 6, 12, 18, and 24 inches. Bridge the transplant for up to 30 days. Log 14 days of draw. Calculate the hottest 7-day average. Multiply by 90. Add 20%. Only then expand. The title is true when the system stays filled. A buried clay pot can water a garden through a 3-month season. It cannot ignore weather, roots, cracks, salt, or an empty reservoir. Where do you garden? What soil and summer heat shape your refill interval? Which of these 8 parts will you test first? Drop those field numbers in the comments. The right answer is different for Pueblo wind, Arizona sand, and a humid raised bed.